Howdy guys, welcome back to cruzermans inventions. This is a 36 pole washing machine motor as a generator. And so I'm going to show you guys what it can actually produce in the way of AC power. And I'll put a bridge rectifier on there uh, and show you what it can produce in DC. And I'll quickly just hone in the camera right here, right there guys. Geez, there must be my front picture to this. I just seen it glitch right there. So that is a window wiper motor, and I put a big sprocket on there like that. Now, if you're familiar with those motors, they're actually a worm drive system, so hard to stop. And yeah, small sprocket over here. That's the original bearings out of the washing machine. Just housed it, made a chrome stand, and welded it to that and bolted it to the ground. Right, so these three phases coming out of here, guys, it's your positive, negative, and earth, red, blue, and yellow. In this case, it's brown, blue, and green, or yellow. So that's positive, negative, earth. It's alternating current, it could be any which way, but I mean, that's the proper way. So in the back of here is the way it's supposed to be wired. So I got that one done, so I can put the tester in one as I'm running this, so you can see the voltage that it's producing in AC on this side, AC, and I'll flick it back over to DC side as well. So let's have a look, guys. I got this. As you all know, the window wiper motor down here is an actual DC motor. That's an AC motor. So this is a DC controller, and it's 24 volt at 40 amps, but we're only running two 12 volt batteries in series to create, and they're only what are they, longs, and I think they're only 7 amp hours, these ones. Yeah, there they are. So two of them in series, and I'm just taking it out of here from the negative and the positive from that side straight out to switching between the positive side straight to the controller with a voltmeter in between. Let's flick it on. So as you can see, guys, the lights are lit up in here, full power on these batteries. Now instead of throttle, I've got a potentiometer here. Now as you'll realize, guys, these things, they don't kick on straight away until they're way around past about 12 o'clock. You reach 1 o'clock here, and then the thing starts to move. It's because of the load capabilities of these things. That's why it's not responsive like a hand throttle. They're built different. Here we go. So just off that alone, that's just the beginning trickle. We're hitting 60, and as I'm turning it up, more and more and more, 100, more and more and more and more. I'll just keep it at 200 right there. I want to show you the speed of this. It's not turning very fast, guys. Look at this. I don't know, I can hear some of you say, yeah, well, put a load on it, put a load on it. I will in a minute. I'm going to ramp this up to what it can produce. Now, it can produce more than this. This is 306, but this motor can't spin any faster than that unless I put a bigger sprocket on it. But that's ample amount of power. Let's dip it down a bit. Let's take it back to, let's take it off for a minute. I want to plug something up. I've got a light bulb here, guys. So I'm going to plug this up into the other side of the socket here. And we're going to see the voltmeter as well as the lights going, right? So, okay, let's ramp up the switch gain. Here we go. Oh yeah, you can hear the draw. We're at 170. Yeah, the light's on. The light is on. Now we'll go higher and higher to 250. I wouldn't want to take it past 250. But to kick this light bulb in, this is real funny. I'll stop it for a sec, right? And we'll go to 120. And this is what actually kicks the bulb in. See, it's on at 120. Now I'm going to dip it right down. Oh, look. See what's happening? But it's still on. And now we're only at 76 volts. Now I can take this thing right down to about 50 volts, and that light bulb's still on. but it's dimmed down, but it's still on. And look at that. Look how little that's spinning. Look at that. You can see it. Not very much, but the bulb's going. Just. So yeah, 110 to kick it in, and you can dial it way back down to 60 or 70 volts AC. So anyways, good little test. I'm going to flick that off for a minute. That's just picked up a little bit more speed, not by much though. So now what I'm going to do, guys, is I'm going to show you something else. Through this, I'm going to change this from AC to DC. Now, if you look at this plug here, I've just used a plug, and this is a bridge rectifier, and it goes in AC and then comes out to DC. So I got my two here and here, my positive and negative out of DC. So what I'm going to do is plug this one in, turn it on, and I've got this my e-bike here. See this? The carcass electric bike. It's 72 volts, running off a 1,000 watt controller at 48 volts, but you can ramp them right up to 80. We get 80 volts worth of DC batteries under the tray and another couple there, and that's running the alternator here. It's running 24 to the center mag. It's a massive amount of power. So what we're going to do, I'll just put you here on the stand for a sec. We're just going to plug up this cord, positive and negative, and hit it straight to the bike. Alright, meter's on there, but that's in AC, measuring in AC, right? So this is on. This is where you got to be careful, because in DC this thing ramps up even through 2 legs, way up to 200. So what I'm going to do is I'm going to turn on the bike, and you can see the meter here. Try and get that glare out. Okay, so it's 75.1. Now I'm going to slowly hit this control on, just until it comes on. Don't want too much power at first. Come on. Here we go, it's away. Okay, it's just started. Now we're reading 55 AC. Want to just ramp it up a fraction, 60, bit more. I want to be charging my 72 volt battery, so I need it at about 75 at least, maybe even more than that. Oh yeah, I can hear this thing groaning a little bit now. Oh yeah, that means it's working. 80, 81, 80, AC. Okay, now let's look at the meter, because it's actually charging. Well, it should be charging. Yep, it's going up. Here we go. And fast too. Look at that. So those washing machine motors are 10 amps, stock standard. There we go, it's going up 70, 78. Yeah, and pretty fast. Look at that, that's a powerful charger. Holy cow. It's way faster than any wall charger, that's for sure. So you're gonna have to watch your batteries and stuff, the heating of stuff. Look at that, it's not even turning that fast, guys. Just trickling away. Beautiful. Absolutely gorgeous. Beautiful. So yeah, let's have another look at the meter. Good lord, we're just about up to 80 volts nearly. It's 79.2, 79, and it's going up and up. So yeah, it's interesting, alright. You're probably thinking, well, what are the volts down here like? Is it dipping out? It doesn't seem like it is. It's still on full power. We're reaching 81 in the AC line, but we're coming out, remember, in here to DC, into the cord and back into the bike, and it's charging as the unit's on. You wouldn't want to hit that throttle as it's charging. Well, not, you can, but not really, just in case you went over the volts, but it's got circuit cutouts, over volt cutouts in these things anyway, so it'll just turn itself off until you come back down in volts. But really, you don't want to over exceed 80. I'm going to whip that back a fraction. Alright, so that just gave you a little idea of the gen, guys. So let's have a look at the settling volts. Okay, it's come back down to, yep, 76. I can make this settle at close to 80, but that's good. You only wanted about 77 anyway, so that's cool. Awesome. Oh, lovely. Didn't take long at all. Alright, so this is the other one, guys, and this is also on my channel. And I run this through the same sort of bridge rectifier, and also the 3 legs coming out going through another sort of bridge rectifier, which is more full bridge. That's out of an alternator, so getting even more power. And this here is charge coils out of a Kawasaki motorbike, 350 I think it was. So yeah, pretty interesting, guys. This has been a long video. So I know some of you have a lot of interest in this sort of stuff, and I actually have rewired a few of those motors from 12 volt to 24 to, I missed out 36, but I've done a 48 volt one, and it's just neat to see what they can actually run, though. I did try and run a toaster on it earlier. It wouldn't run the toaster, wouldn't run the jug. You know, it's limited to what you can run off them, but you can run all your small appliances like your phone chargers, charging up bikes or whatever, your e-bikes, and lights. Lights are another good thing. But if you made a windmill out of these would be real good. Awesome stuff, guys. Hope you enjoyed that. Whew, that was 2 days straight building that sucker. After I got a little comment about, generators and stuff, but I will make a comeback with a part 2 of this, with a whole different uh, coil system in here, one that's been revamped, and we'll just see what that produces. So yeah, that stock aluminium one, weirdly enough, still produces heck of a lot of power for aluminium. So interesting. Cool, guys. See you in the next vid coming up. Cruiser Man out.